All right, so here are the notes that we started taking on Monday night, Tuesday night. Some of you are doing it Wednesday night. So this is part 2 where you already made the foldable. Now we're going to fill in the exponential and the quadratic. So in class on Tuesday and Wednesday, you were working through this I rule, I cite activity, noticing this was linear. And this one was not linear, was not exponential, and most of you figured out that this was 112 was the total, and you noticed your growth was changing, you explained all that to me, but now you were having a hard time because question 4 says what's the rule, and you don't know what to do with that. So you're asking me, are we going to do the notes soon? So here's your notes to help you. So we're going to focus on the exponential. So we're going to keep the top one closed so it's out of our way. And this side is our explicit. Oops, it's not writing. I'm going to write underneath it. This is your explicit equation. I made a mistake and went over whiteout and it didn't work. And this over here is our recursive equation. And so our table we're going to use today is x and f of x. And then this is -1 gives us 4. 0, 16, 1, 2, 3. 1 is 64. 2 is 256. 3 is 1024. And so our job is to find out what our equations are. So the first thing you guys are trained on doing now is you want to see what that pattern is. And a lot of you can figure out that when you go 4 times 4, you get 64. So you're going to guess that it's times 4. And then you're going to test it. And 16 times 4 actually is indeed 64. And so the pattern works. And so this is our growth and our y-intercept. I was nice and gave you it in the table, is right there, 0, 16. So our explicit equation, and again, you've already seen this in other notes, but we're going to have it in this foldable. Y equals a times b to the x, and a, I should have made in green. A is our y-intercept, so that's our y-intercept over here. That's our a, and our b is this right here, which is our growth, which you have right here. So this is blue and the A is green, and X is in the exponent this time. So let's put our little notes to help us. The other way we could write this would be f of x equals, and then I'm going to use the colors better, f of 0 for that first term times our b term to the exponent of x. And so b is same thing as a, which is my y-intercepts. And then b is the same b there, which is my growth, or also known as your, could be decay if you're decreasing, or it is your common ratio. Just depends on how you were taught and how you look at it. But it's this times 4 right there. So for this equation, for this table, we can write our explicit f of x equals 16 is my y-intercept. So I'm going to put 16 times, and then b is my growth, 4 to the x power. And it's really tempting to go 16 times 4 and then to the x, but remember, you do exponents first in order of operations, then you multiply. So you have to do this before you multiply. So you may not combine these together and tell me it's 64x. That's not true. It's 16 times 4x. So that is my explicit equation for this one. And the recursive is very similar to what you had for the linear, except now we're just multiplying. So it's f of x equals, take the term before, or that f of x minus 1, and then we need to multiply it. In this case we're multiplying, so we're going to multiply it by 4. And, oops, that's my answer down here. This should be B. We'll just make that into a B. So it's times B. And then B is my growth. For B is my multiplier. B is my common ratio. So if you were to go 64 divided by, oops, never mind, I can't even go there, just kidding. So your ratio is, you're multiplying by 4, that's your growth, leave it at that. Could be your decay, same stuff that you had on the other side. So this should have been B. I'm going to fix that mistake. If you ever need to watch this again, rewind it, or if you ever need to do anything, you missed something, you always pause and rewind. Or you can always come look at my notes if you want to see something closer up, because I can't zoom on this for some reason. So now let's worry about this. Let's put a note here that says you need a point. And I've been referring it as an address, so we're going to put that need a point as the address. And same thing up here. I didn't write it on the linear one. Let's go write it right now. So need points as the address. I did talk about, and I'm talking about in class, how you need to make sure that you know where this line is, or in this case where this exponential function goes, so that we need a point as that place and nail it down. So our explicit is two parts. It is the first part, f of x equals f of x minus 1. Now I'm going to put my times 4 down here, times 4. And I'm going to use the address. I like to use f of 1 when it's there. So that's this right here, f of 1 equals 64. And I'm going to actually draw an arrow so you know where that came from. That's where this came from. When when x is 1, f of 1 gives me this, which is 64. So that's the exponential. Again, it's Math 1 review. If you need a lot of help on exponentials, let me know. We'll go over more details. But I want to focus on the quadratic now for the next 10 minutes, not even 10 minutes. So on the quadratic, we know this is like what we have right now. We have to be really careful with our tables, and we're going to have a lot of writing to do. So I'm going to be creative and clever with how I put my information. Way over here on the side, I'm going to put explicit equation. And you see I'm leaving myself a lot of room there. Explicit equation. Way over here, I'm going to put recursive equation. Okay. And so on my table here, I'm going to actually use this as my middle. And we're going to have 4 columns. We haven't done a table like this yet. Some of you did actually in the first task that we did. But we're going to have our x, we're going to have our f of x, and then that growth pattern we've been looking at, that's actually my first difference. I'm going to put first difference, and then I'm going to put second difference. And so I'm going to do lines all the way across. So this is -2, -1, 0, 1, and 2. And then the y values, the f of x values are 7, 4, 5, 10, 19. And so when I look at this, I'm like, oh, well, that's going down, and then it goes back up, and that's kind of actually a pattern you're going to see with quadratics, because if you think about what's happening, you're going to go down and then come back up, or you're going up and then you're going to come back down. So you'll see those patterns show up. So I want the first difference. I'm going to give you a hint so you don't confuse yourself. When you're doing your difference, be careful that you go from this arrow down and across, and the difference goes in the box to the one you're going towards. So go from 7 to 4, I am subtracting 3, so I'm going to put -3. From 4 to 5, I'm adding 1, so I'm going to put 1. From maybe even a +1. From 5 to 10, I'm adding 5, and from 5 to 19, I'm adding 9. And if I look at these, I'm going subtract 3, +1, +5, +9. There's a pattern going on. I don't have anything here, and that's okay. And I'm going to do the same thing again over here. So I'm going to go down and over. Now my second difference is what I'm going to be looking at. My first difference is not the same. It's not multiplying. It's not adding the same thing. So that's a clue to me that's probably quadratic. But the second difference will tell me. So from -3 to 1, I'm actually adding 4. From 1 to 5, I'm adding 4. And from 5 to 9, I'm adding 4. The second difference will be the same if it's quadratic. So this is +4, +4, +4, and I don't have anything in those two boxes. You might have to go back and fill them in depending on the situation. So my table is done. Now we've got to learn our way that we write this. So I'm going to come over here and I'm going to write f of x. I'm going to see if I can do a little bit bigger for you. Equals, the general format is ax squared plus bx plus c. So you're going to have an x squared term for quadratics, and then this is kind of like linear, slope plus y-intercept, and it kind of is all the same. So now the a, I'm going to make to be actually a new color. I'm going to make a red. And so A is red. Your A you can't get just from your table directly, but the way your A is found, your A actually equals the second difference divided by 2. So this would be the second difference divided by 2. So in this case, it's 4 divided by 2. So in this case, A equals 2. And you'll see that in a minute. So we'll do little notes here that says that A equals the second difference divided by 2. So that's really important to know. Find the second difference, divide it by 2. That tells you your A value. Your B value, you have to kind of, there's a few ways to do it, but we're going to take some room to show that. We're going to leave that alone. Your C value, I'm going to make this green again because it corresponds to the other greens. That is your y-intercept right here. So in this case, it's going to be 5. But B, we have to do some work for. So I'm going to put a little note here that says B, you must solve to find. And this is where students get the most confused usually, is finding B. And we're going to do lots of practice. Okay? So I'm going to go talk about the recursive equation in general. We'll find our recursive and then come back to the explicit. So for the recursive, we have f of x equals f of x minus 1, that's the same, plus, this is your second common difference. So I'm going to make that be blue. So this is your second common difference. And that's this right here. That's this part. So that's going to be 4 in this case. And then times x. And then, I don't have room to write all this. Plus, and then this is going to be the first difference at the y-intercept. So first difference at the y-intercept. And that's so sloppy, I'm so sorry. So I'm going to make that be orange. I just ran out of room. So the first difference at the y-intercept. So that's this value right there. The first difference at the y-intercept. So when you do your table nice and neat, it kind of just shows up easily. If you don't do your table neat, it's a lot harder to find. Okay, so For this one, if you look at this part, this is kind of like your linear equation, and then we're just adding on to this is just like your linear equation. So it's the function you had before plus this linear equation. So for our down here, and we're going to go over this in class again, so if I'm confusing you or if you're confused, it's okay, it's new, it's different, and we're going to review it. So this is f of x equals f of x minus 1, and then my second common difference is 4, so that's this 4, and that 4, so I'm going to put plus 4, and this is blue. And then I have my x involved, so 4x plus, and then I look for my y-intercept. The first difference of the y-intercept is right here, and that's a positive 1. So I'm going to put plus 1, and I'm going to highlight that orange for the consistency. So that's plus 1. And then I need an address, so let's put a little note. Again, needs an address, just like the others. And so in this case, I'll just say f of 1 equals 10. So that's the recursive, kind of almost easier in a sense. But now we need to go over to my explicit. I can start writing my explicit fairly quickly. F of x equals, my second difference divided by 2 gives me a. So I'm going to put this as an a. Oops, put this as a 2. That's my a value. And then x squared plus my v value I have to solve. So I'm going to put a space x, and then c here is 5. So plus 5. Okay. So I think this has actually gone over. I'm going to let it keep going, and then you guys can watch in different shifts. So from here, I need to find what this v value is. So I'm going to look at my table. Here's my table. And I'm going to just pick a point. So I'm going to pick this point, plug in what I know, and solve for b. So I'm going to say, okay, let f of 1 equal 10. That's this point right there. Okay, that's where I got it from. You can even draw an arrow to that. So now I'm going to plug in wherever I see f of x, I'm going to plug in 10. So I'm going to go 10 equals, I know my a from over there was 2, so I'm going to even put this in color. That's 2. Wherever I see an x, I know x is 1, so I'm going to put times 1, and then squared plus, I'm trying to solve for b, and then x is 1, so I'm going to put this in a 1 there, and then plus, my c is 5, so I'm going to put that in green here, plus 5. And so now I just solve for b. So that's 10 equals 1 squared is 1 times 2 is 2 plus b times 1 is b plus 5. 2 plus 5 is 7. So 10 equals 7 plus b. And to make that a true equation, b equals 3. So we're going to do that over and over and over again. And so if b is 3, then I'm going to just take that over here, and I'm going to put my 3 in there. And I'm going to actually draw an arrow to show you that's where it goes, is right there. All right. So again, that was a longer video than I wanted to. I'm sorry about that. There's so much good stuff to say. We will do this over and over and over again in class. The first time you're seeing it, get the notes down. Try to do some of the problems I'm going to give you in Edpuzzle. See what you can do. Come ready to ask questions. All right. So again, a is your second difference divided by 2. That's here. Divided by 2 is 2. B, you have to solve. So pick a point, put it in here, solve, and then C is your y-intercept. So that's how we got that. And I'm going to make this 5B green for color coding. All right. Have a good afternoon.